Okay, so we're going to create a virtual machine in the Amazon AWS cloud system. Some people refer to this as spinning up a virtual machine in the cloud. We're going to install Ubuntu server. We're going to set up a security group. We're going to download a key pair. We're going to connect to our server using an SSH client. Then we're going to install remote desktop and connect to our virtual machine remotely. So I'm going to head over to the Amazon website. I access the services from the service menu in the upper left-hand corner. Service we're going to use is the Elastic Compute Cloud EC2. Currently, we don't have any running instances, so we're going to create one. And an instance is going to be our virtual machine container. Amazon system has a bunch of pre-built images that we can install in a virtual machine. This really saves a lot of time and ensures that the operating system you're installing will be compatible and function correctly with the Amazon virtual machine. We're going to install Ubuntu Server 18.04. Select that. And since we're using the Amazon free tier, we're limited in the amount of resources our virtual machine can use. We can use the T2.micro single core, 1 GB of RAM. Elastic block storage is our storage medium, and low to moderate performance networking. It's all perfectly fine for our experiment here today. So review and launch, lower right-hand corner. So we selected our operating system. We selected the virtual machine resources that we wanted to use. It's going to create a security group for us. And we'll take a look at that detail a little bit later. Before we can create this, we need a way of being able to access the operating system after it's been created. And the way that this is done is through a cryptographic key. It's kind of like a password, but it has some enhanced security features to it. So we need to create what's called a key pair. Create new key pair. We need to give it a name. This is going to be a file that we'll download to our computer. Call it AWS test. I'll click download key pair. And you'll notice in my web browser, we downloaded AWS test.pem. Take a look at that file in a minute here, but we'll continue on with setting up our virtual machine. I'll click launch instance. Amazon's getting things ready. We can click on our machine name, virtual machine name here in the Amazon system to take a look at its status as it's being set up. All right, instant state pending, status checks initializing, great. Okay, so go back to this key pair. Now it downloaded an aws.test.pem. This is a text file that contains our cryptographic key. I can open this up in a text editor. Here's my file I downloaded, aws test.pem. I'll drag it into my text editor here. And you can see that it has a whole bunch of random looking characters here, but this is actually the private cryptographic key that it's going to use to gain access to the server. We have a special program to convert our key to the type that we need for our SSH clients. I use PuTTY, and it has a companion program, PuTTYgen, which will allow you to generate cryptographic keys or to convert them in this case. I'm going to load the cryptographic key that I downloaded from Amazon. select all files so we can see the aws.pem. I'll open that file. It's going to let me know that it successfully imported it. And now keys are a key pair. There's a public part and a private part. This private part is what we are going to need to access our new virtual machine and this operating system. So I'll say save private key. It says, are you sure you want to save it without a passphrase? That's fine because we're in a low security experiment here. I'm going to name it AWS test. And the type of file is going to be a .ppk, which is the key file format that PuTTY uses. I'll click save. And now I have a second file on my desktop, AWS test.ppk. Great, so I just converted the key from one format to another. It's the exact same thing, it's just in a different format. I'll close my key generator utility. We'll go back to Amazon, and we'll see that our instance is now running. Status checks are initializing, that's all fine. I have here the IPv4 public IP address. This is where that server will be available to us. So I just selected it, I copied it. Now I'm going to go to my SSH client, PuTTY. I'm going to paste in my host name, that's the IP address. We're connecting on port 22, this is SSH. This port is open by default when you set up this virtual machine because you need some way of connecting to it remotely and configuring it. Otherwise, you wouldn't have any way to actually access it. And when we connect, we're not going to use a password because we're using this cryptographic key. It's considered a more secure way to make that connection. I need to let this program know that for authentication, under the SSH connection section, SSH auth, I can select that private key. I'll browse. Here on my desktop, I have AWS test.ppk. Select the file, open. And now when I connect to this remote server, it's going to provide this key as a way of accessing a user account on that remote machine. So now that I have my key selected and under session, I have the IP address, the correct port, connecting SSH, I can go ahead and click open. First time you connect to a new server, it's going to warn you that basically, since you have initiated this connection manually, that there's no way for this client to guarantee that it's connecting to who you think you're connecting to. Now we put this information in ourselves, we just created this virtual machine so we can feel confident that this is all good. Even though I can't guarantee the authenticity of what we're connecting to, we know that it is what we're intending to connect to. So I'll say yes. Now in the Ubuntu virtual machine in Amazon, the admin user name is Ubuntu also. This is just something I had to Google or looked up in the help file associated with this virtual machine I installed. For other operating systems, it will be different. Ubuntu is the username, and it says authenticating with our cryptographic key. Message just disappeared off the top of the screen. But that's what we've used in place of a password. Tells us we've connected to Ubuntu 18.04. This is the message of what's called the message of the day. It's just giving me some details about the system. Good, so we set up a virtual machine in the cloud in the Amazon AWS data center. We installed a virtual machine image, Ubuntu, and now we've connected to that virtual machine through SSH. We're at the command line of that remote server now. Go back over to my notes. And one thing that we always want to do when we install an operating system, really of any sort, is to make sure that it's updated. This is just a good practice. It's really not necessary for our project today, but this is good practice, so I'll just show you this. We're going to run two commands that are joined together with this double ampersand. The sudo is a command that tells the system we'd like to run this command, the following command, as administrator. And what we're going to run is apt-get. That's the software installation tool in this form of Linux. Update means check to see if you have any updates. And then the second command, run as administrator, sudo apt-get, and then upgrade. It means if you have any updates, go ahead and upgrade this system. So I'll go back to my SSH window. I'm going to paste with a right click of the mouse. I hit enter. It's now going to check to see what updates are available. And then it's going to say, I have found all these files. All these software packages should be upgraded. So if I hit enter, the default, yes, it's going to begin upgrading our files. Back to my notes. There are a few Linux commands that you may want to know about while the installation's running. I'll just review these quickly. apt-get is the Debian-based Linux software install and management system. It's really a great package manager that will install or remove software, update the operating system. We have ls, which is a way of getting a directory listing. For the place you are currently in your file system, it'll show you what files exist there. In DOS or a command prompt in Windows, you would type in dir. It's the equivalent command. PWD is sometimes helpful. It will show you where you are currently in the file system. It's usually part of the prompt itself, so you generally don't need this command, but in case you do, it's there for you. As I mentioned, when you're working with virtual machines and remote desktop and remote connections, you end up in these kind of inception-like layers of sometimes you forget where you are and who you're logged in as. So Linux has some commands that help you sort this out. One of them is who am I? It's going to simply tell you the username that you're currently logged in as. Again, usually part of the prompt in the SSH window, so you generally don't need this command, but every once in a while it comes in handy. Next command is process list, ps. And I've added in here a switch, -aux. In Linux, when you want to modify a command, you can add a switch like this. And these letters, A, U, and X, will modify how PS will run and what kind of information it's going to display. You can always look up the list of switches and how commands work in Linux by typing in man for manual, and then the command name. So man ps would show you the manual entry for the process list. -aux is a very common one to use because it shows you the things you're most likely to need from this command. df will show you how the file system's being used, what different storage devices the file system has defined, and how much of their space has been used. We mentioned sudo already. It means simply to run the following command as the administrator. So anytime I write sudo and then a command, it will be run with the highest level privileges that the system will support. Sometimes we call this root because root is generally the administrator of a Linux system. Run as root, run as administrator, same thing. And again, great system built into all Linux distributions is the man command. It's the manual for whatever command that you'd like to run in the system. It's sort of like a built-in Google of the Linux command line system. All right, so the next thing I wanted to do with my server was to set up a desktop graphical user environment and set up a remote desktop system. This is something you've experienced in a class, so I wanted you to be able to see something similar to what you're familiar with. And I haven't done anything like this in a long time, and so I had to do some research to figure it out. I did some Googling, I came up with some links, and what I have here are some of the examples that I came up with. Um, to be honest, I started following some of these instructions and these links, and I was really having a lot of trouble. And then I realized Ubuntu 13.04, Ubuntu 14.04. These are fairly old versions of Ubuntu. So some of these articles were years old. Some of the information was out of date, and so I really had a great deal of difficulty. I had to redo this lab several times, and that's not uncommon when you're doing something new. It's just an experiment too, so there was no pressure to get it right the first time. Third time through, I found an article that had to do with a more recent version of Ubuntu 18.04, which is actually the server we selected. Probably work in the latest version of Ubuntu as well, but the instructions pretty straightforward there. And here are my notes on what I figured out. First thing we want to do is to install that desktop software, the graphical user interface for Linux. Right now, all we have is a command line, and that's nice, but it doesn't look like things you're familiar with, so we want to bring that graphical user desktop into the mix here. We're going to use XFCE. That is the name of a desktop environment for Linux. It's a very lightweight desktop. It doesn't take a lot of system resources, and I thought this would probably be the best bet for doing a remote desktop to a virtual machine that has very limited resources. So here's the command. It's sudo, means run as administrator, apt, which is our package manager. We want to install the following items. And this is the software that most people would want to install for this particular graphical user interface. I'll copy the command, head back over to SSH. Our update has completed. I'll paste in our command. And there's quite a few software packages that need to be installed to make this graphical user interface work. All right, I'll begin installing that. And while it's running, we'll go back over to my notes. Next thing we want to do is to install a remote desktop service, RDP. So we want to connect to a graphical user interface remotely. So we're going to use some type of remote desktop protocol. In this case, there's a package called XRDP, which will allow us to do it. There's a few different options here. Ubuntu has some things that are built in. We can use something like a commercial offering like AnyDesk or TeamViewer, what have you. But this is nice because it'll use the built-in Microsoft Remote Desktop application that all Windows systems will have. Copy the command. We'll go see if our desktop is finished being installed. It's still working. While we're waiting, we'll just look ahead to what we're going to be doing next. After we install our remote desktop service, we're going to have to create a user. We want to create a user so that once we make this remote desktop connection, we have a user account to log in with. Once we have these things, we have a working operating system that we accomplished up above. We installed the graphical user interface. We installed our remote desktop service. We created a user. We're ready to go. We want to connect with our remote desktop at that point, and we're going to run into a little bit of a problem here. We're going to do a little exploration for why it's not working. And then we'll see if we can make it work. All right, we'll just let this finish up here. Great. Graphical user interface is installed. Now we're going to install our RDP surface. Should just take a moment. And so unlike Windows, where you might go to a website and download a program through your web browser, run it, go through the installation process, this is really streamlined in a Linux system if it's part of the Debian package management system. Okay, great. Got our RDP installed. Next, we want to create a user, and we're going to create test user. Great. And so we always want to use strong passwords whenever we have a internet-facing service. This is available to the world. People will be probing this system, looking for weaknesses in it, try to compromise it and use it for whatever nefarious purposes. So picking a good password is an important thing to do. I already had one in mind. All right, here are the details for the user, which not important to include at this time. Great, so the user's been created. Next up is to connect with RDP. And if we wanted to create this password the correct way, we'd really use a password generation tool like LastPass or a similar service. It's going to create a good random password that's sufficiently long, has sufficient randomness, and special characters, uppercase, lowercase, numbers, and the whole bit. All right, great. So we need our public IP address in order to connect through remote desktop. Head back over to the Amazon interface. I'll copy my IP address out of the console here. Going to open up my remote desktop connection application in Windows, and I'm going to click connect. So as I already told you, this is going to fail. And the reason why it's going to fail is that the security on Amazon is going to prevent this type of connection by default. By default, Amazon's only going to allow traffic on port 22, so you can connect a secure shell and do whatever it is you need to do with your server. Remote desktop is not something that they're going to enable out of the box because they only want you to enable it if you're going to be using it. And maybe we want to take a closer look at our server here. Have the graphical user interface version of Nmap. I'll paste in the IP address of my server. I'm going to choose regular scan. Click scan. And now it's going to be sending out requests to the server, trying to figure out what types of requests that remote server will accept or not. And currently, it's only finding that port 22 is open. All right, that's what we'd expect. That's what I told you would happen, and that's what I discovered happens when I set this up the first time. Great. So we need to go back to the Amazon console, and our security is managed by a security group. It's down here under Network and Security. You can take a look at your network interfaces and see what security groups are applied to them. So we have Launch Wizard 1, View Inbound Rules, View Outbound Rules. So this is like a firewall, a virtual firewall, and it has firewall rules defined that will allow traffic to come into the server and to go out of the server. You can also access this directly through security groups. This link on the left. Let's take a look at the outbound rules. All right, saying all ports, all protocols, going anywhere are allowed. So it's wide open. The outbound is wide open. It's kind of a normal thing and a more secure setup. You may want to lock down any outgoing traffic that your server should not be producing. If your server is compromised and new software is installed on it, it's not going to start sending out spam mail or what have you if you have those outgoing ports locked down. Again, just an experiment here, so this is okay. If we view the inbound routes rules, we'll see again, port 22 on protocol TCP from anywhere is allowed. Okay, so anyone in the world can connect through SSH if they have the proper credentials, that cryptographic key. So that's a point of vulnerability of your server. You really have to be careful with that. And this is a pretty good setup for a default server because they don't know where you're going to be connecting from. So they kind of need to allow anybody to connect to the server. But it's only allowing you to connect through SSH, and it's only going to allow you to connect with a cryptographic key. Pretty good system. In a real setup, you'd want to further lock this down because you don't want the world to be able to SSH into your server. You'd only want certain people to be able to do that. So let's go ahead and take a look at the security group. Here's the inbound rule section. Here's our current rule. And we want to edit the rules. We want to add a rule. And now what we need to know is the port we need to add for RDP. This is something we can Google. Okay, by default, server listens on TCP port 3389. We'll just copy and paste that, so less likely to make a mistake. Back to our Amazon console. We'll paste in 3389. That's the port that we want to open. It's protocol TCP. And the source is basically, well, where is this coming from? That could be very specific. I only want it to accept a connection from the IP address that I'm physically located at, this computer I'm sitting in front of. In this case, I'm just going to leave it wide open, though, to simplify the process a little bit. Not the best security process, but it's going to be okay for this experiment. Scroll down, I save rules. Great. I get a message, hey, you've modified your inbound rules. All good. Let's just verify that with Nmap. We'll rerun our scan. And just as we'd expect, port 22 is open, and now port 3389. We'll go back to our remote desktop, and we're going to try again. And we get a different one. Again, it's saying we can't guarantee who it is that you're connecting to right now. But since we put that IP address in ourselves, we feel confident that we're connecting to what we know we're connecting to. And here, in fact, is the login on that remote machine. My username was test user, and the password. And we've remoted into our remote desktop.